of a power. So we're going to start with a little investigation. Our question says, consider the following examples. So example number 1 is 2 to the power of 4, and then in a bracket, to the power of 3. So this has 2 different powers on it, a 4 and a 3. So the outside power of 3 means that 2 to the power of 4 is getting repeated or multiplied 3 times. So this is the same as 2 to the power of 4 times 2 to the power of 4 times 2 to the power of 4. We learned that when you multiply things with the same base, you leave the base the same and you can add the exponents. So I added 4 plus 4 plus 4. So I have 2 to the power of 4 plus 4 plus 4. And 4 plus 4 plus 4 is 12. So my final answer here is 2 to the power of 12. In our second example, we have 8 to the power of 10 to the power of 5. Just like in the first example, that outside power of 5 means that 8 to the 10 is being multiplied by itself 5 times. When we multiply things with the same base, we can add their exponents. And when I add 10 plus 10 plus 10 plus 10 plus 10, I get 8 to the power of 50. So the question I have for you is, there is a shortcut for getting from the original question to the final answer without doing the middle steps. So what is that shortcut? So I'd like you to think about that. Think about that original question, that final answer. How could you get that without having to do all that work in the middle? So hopefully you noticed what I noticed. In the first example, 4 times 3 gives me 12, and 10 times 5 gives me 50. So to simplify powers on powers, you copy the base and you multiply the exponents together. So we're going to try a couple of examples of that. So it says simplify each of the following using exponent laws. So our first example is 2 to the power of 7 to the power of 2. So since I have a power on a power, I can multiply those 2 exponents together. So I get 2 to the power of 7 times 2, and then 7 times 2 is 14. So our final answer is 2 to the power of 14. The question did not ask me to evaluate. If it did say evaluate, I would work out what 2 to the power of 14 is on my calculator, but it just said simplify. So I just have to write it as a power. Our next example, I have 2 to the 10 to the power of 2 to the power of 3. So since I have a power on a power, I'm going to multiply those powers together, and 2 times 3 is 6. So it is 10 to the power of 6. Now, the last one looks really complicated. It has a lot of powers. It has 3 to the power of 2, to the power of 3, to the power of 4, to the power of 5. When I have a power on top of a power on top of a power, I multiply them together. So I get 3 to the power of 2 times 3 times 4 times 5. Now, you could do that all together, but I did it in little steps. So 2 times 3 is 6, and then 6 times 4 is 24. And then 24 times 5 is 120. So I got 3 to the power of 120. Now we have learned 3 different exponent laws so far. We've learned what we do when we multiply things with the same base, what to do when we divide things that have the same base, and what to do when you have a power on top of another power. So we're going to try some questions that involve all 3 of those rules. And if you're ever unsure of what to start with, you should always think about order of operations and follow your BEDMAS rules. So I start with B. If I have things to do inside of a bracket, I will start with that. And then if I have something that has an exponent on an exponent, I'll do that next. And then if we have division or multiplication, I will tackle that next. And then none of these questions will have addition or subtraction in them. So our first question, 5 to the 3 times 5 to the 9 to the power of 2. I notice that I have multiplication, but I also have a power of 2 on top of one of the brackets. So that power of 2 is not on the whole thing. It is just on the 5 to the power of 9. So I'm going to start by doing the power of 2 on 5 to the power of 9. So when you have a power on top of a power, so when you have one base and 2 exponents, you multiply those together. So I'm going to leave the 5 to the 3 the same, and then multiply 9 times 2, which is 18. So I have 5 to the 3 times 5 to the 18. Now, these are being multiplied When we multiply, the rule is that you can add the exponents together as long as they have the same base. They both have a base of 5, so I'm going to add those exponents together. 3 plus 18 gives me 5 to the power of 21. Now, that's my final answer. It just asked me to simplify. I don't need to evaluate. In question B, I have a very large bracket, and inside the bracket, I have w to the power of 9 divided by w to the power of 4, and then all of that is to the power of 11. So when I'm working my way through order of operations, if I have brackets and something to do inside the bracket, I will start with that. So here, the w to the 9 and the w to the 4 are inside the bracket, and they are being divided. So since there's something to do inside the bracket, I'm going to start with that. So when you're dividing two things with the same base, we subtract the exponents. So w to the 9 divided by w to the 4. I subtract 9, take away 4 to get w to the power of 5. And then that still has a power of 11 on it. Now, I notice now that I have one base and two exponents. So I have a power of 5 and a power of 11 on the same base. So I'm going to multiply those together. 5 times 11 is 55. So my final answer there is w to the 55. Our last question, a to the 6 times a to the 10 divided by a to the 3 to the power of 2. I'm going to try to simplify the numerator, then simplify the denominator, and then we'll try to do the division. So if I do follow BEDMAS, it says I should do the exponent first, but because I have the numerator and the denominator are separated by that division line, I can work on both of them at the same time. So if I start with a to the 6 times a to the 10, when we multiply, same base, we add our exponents. So 6 plus 10 is a to the power of 16. On the bottom, a to the power of 3 to the power of 2, that just has one base with two exponents. So I multiply those two exponents together. 3 times 2 is 6. So I get a to the 6. And then from here, it is just a division question. A to the 16 divided by a to the 6. We don't divide our exponents, we subtract. So 16 take away 6 is 10. So I get a to the power of 10.